Alright, so we're going to be going through the third section of the probability unit, which is Unit 7, and it's on binomial probability. Now, binomial probability is used to find the probability of something happening more than one time in a certain number of trials. So if you try something 5 times, what's the probability that you are successful 3 times? If I'm flipping a coin 10 times, what's the probability that I get exactly 5 heads? So that is binomial probability. So binomial probability, by definition, is the probability that an event will occur X times in Y trials. And it's also important to note that there are only two different outcomes. So you have success and you have failure. There's only 2 things that can happen. You can be successful in what you're doing and get what you want, or you fail at what you're doing and you don't get what you want. It can't be multiple different outcomes. So, for example, what I mean by that, if you're flipping a coin, outcome 1 would be something like heads, and outcome 2 would have to be the only other thing that can happen, which is tails. Rolling a 3 on a die. Well, there's 2 things that can happen, really. You can roll a 3, or you can roll any other number. So basically, being successful would be rolling a 3, and being not successful would be rolling anything else. A 1, 2, 4, 5, or 6. If you're talking about an election, the candidate can win, or the candidate can lose. Those are the only 2 options. So that second one there is kind of the important one, where it's talking about when there's more than one possible thing can happen. Really, you can either be successful, you can roll the number that you want, or you roll something else that makes it not successful. So, if we roll a fair die 4 times, what's the probability that we get exactly 1/6? Well, when we want several events all to happen together, we need to remember that we multiply. When we want one event or another to occur, we add. And that's coming from the last section on probability. So what are all the possible ways to roll a 6 in 4 rolls? Well, you can have your 6 first, and then 3 other numbers that are not 6s. You can have your 6 second, with 2 other numbers afterwards and 1 before it that are not 6s. You can have it third, or you can have it fourth. Either way, there is only 1 6 out of each of these 4 rolls. So if we want to find the probability of each of those, we're going to look at each piece individually. So the probability of rolling a 6 on the first roll would be 1 out of 6. And then everything after that, the probability of not rolling a 6, here, here, and here, is going to be the other 5. So we're going to have 5 out of 6, 5 out of 6, and 5 out of 6. So we want to remember that if we want each of these things to happen, so we want this first, second, third, and fourth thing to happen all together, we're going to end up multiplying those. And this will give you, if you put it into a calculator, 125 out of 1,296. So for the second one, we want to do the same thing. This first choice here, we have 5 out of 6 things we can get. The second one, we want to get the 6 there, so that would only be 1 out of 6. And then again, you'll have 5 out of 6 and 5 out of 6 for the next two. And again, we will be multiplying all of those. So 5 times 1 times 5 times 5 is again 125. And 6 times 6 times 6 times 6 on the bottom is again 1,296. You might be seeing a pattern here already. For the third one, the probability of the blanks, as we've already figured out, is we have 5 options out of 6. 5 options out of 6. 5 options out of 6. And for that one where we're actually looking to get our 6, it's going to be 1 out of 6. So hopefully you notice that when you multiply these one more time, you get 125 out of 1,296. And that last one down on the bottom there is going to give you almost the same thing. We have our 4 blanks, which are our 5s out of 6s. And our last one there, where we get our 6, is going to be 1 out of 6. So again, we would multiply those out and get 125 out of 196. Sorry, 1,296. And the very last thing that you need to do there is either we want our 6 to be first, or we want it to be second, or we want it to be third, or we want it to be fourth. So we want one of these things to happen here. And if we recall, when we want one event or another, we're going to add. So if we add all those up, so we take our first one, plus our second one, plus our third one, plus our fourth one, you actually end up, I'm not going to write it out here just for lack of room, you'll end up with, when it's reduced, 125 out of 324. Because you would add all the tops, your calculator will reduce it for you, and that ends up being your final answer. So the probability of rolling a 6 exactly one time on 4 dice rolls is 125 out of 324 tries. And as we noticed already, all of those options have the same probability. And before we move on to this next part, we want to remember that the number of ways to get 1 out of 4 when the order doesn't matter, so it didn't matter if our 6 was first, second, third, or fourth, we use combinations. So, to find the probability that an event will happen r times in n trials, there's a formula we use. And it starts off with that combination. So we're taking the number, we're taking the number of trials, and we're choosing r successes. So we know that n is the number of trials, and r is the number of success. And then we're going to take our probability of failure, so how many times do we fail? So f is going to be probability of failure, and we're going to raise that to the n minus r power. I'm going to put that in parentheses. And we're going to then take our success, which is the probability of success, and we're going to raise that, again I'm going to put it in parentheses, to the r power. So the whole formula, if you read it all together, is NCR times the probability of failure to the n minus r times the probability of success to the r power, where n is the number of trials, r is the number of successes, f is the probability of failure, and s is the probability of success. You'll see it is actually a lot easier than that sounds. The whole formula sounds kind of complicated, but when you get moving through things, it actually ends up to be a little bit simpler than it sounds. It might also be important to add, if you heard my wife just whisper that to me, which I had in my notes but I did not mention, is that these two numbers here, your f and your s, are going to be fractions. So f and s, you probably can't read that. Let me change the color quick. F and s are fractions, because they are probabilities, so it's going to be something out of something else. So, looking at an example here. A cereal company puts a coupon for a free box of cereal in 3 out of every 20 boxes. What's the probability that Miss Sullivan will find 2 coupons in the next 5 boxes she buys? So there's a couple things we want to find here. First, we want to find what n is. What is the total number of trials? Then we want to find what r is. What is the number of successes we're looking for? Then we want f, which is our probability of failure, and we want s, which is our probability of success. So reading through here again, a cereal company puts a coupon for a free box of cereal in 3 out of 20 boxes. So that right there tells us what our probability of success is, 3 out of 20. So success is going to be 3 out of 20. What is the probability that Miss Sullivan will find 2 coupons? So we want her to find 2 coupons. That's how many successes we want. So R is going to be 2. That she finds 2 coupons in the next 5 boxes. So our total number of trials is going to be 5. And now I know what you're thinking. I know exactly what's going through your head. It's, Mr. Sheehan, they obviously didn't give us enough information to figure this out, because we are missing our f here. And to find f, we need to think back to that important note that we said yesterday and the day before, that if you have a certain event, when it is certain it's absolutely going to happen, the probability is 1. What also so happens that if you have success and failure put together, your only 2 choices are those. So the probability of one or the other happening is going to be 1. So if you have your failure plus your success has to equal 1. So failure in this case plus 3 out of 20 equals 1. And to solve that equation, you would go ahead and subtract 3 over 20 from both sides. And when you do that, these would cancel out, and you would end up with f, I'm going to bring it up to here for us, f equals 17 out of 20. And you can do that for every single probability that there is. If they give you the probability of success, you can do 1 minus that to get the failure. If they give you the probability of failure, you can do 1 minus that to get the probability of success. So let's actually make a note of that real quick up here. 1 minus success equals failure, and 1 minus failure equals success. So that's how you find the other one. They will only give you 1. You'll have to do that little subtracting deal to figure out the other one. So now let's plug this into our formula. I'm going to rewrite it here. It was NCR, F to the N minus R, S to the R. So now it's literally just plugging things in. So we have 5C2. Our probability of failure is 17 over 20 to the 5 minus 2. Our probability of success is 3 over 20 to the second power. And then you can literally put that all into your calculator. When you put it into your calculator, it spits back this crazy thing like 0.138178.125. And that sounds ridiculous, but your calculator actually will not change that to a fraction because it is an irrational number. That's really all there is to it. You find, to recap real quick, you find the number of trials, you find the number of successes. They will give you one of the two fractions that you need, one of these two probabilities. So in this case, they gave us success. We use this little subtracting trick here to find our other probability, and then you plug it in. And after that, it's just plugging it into a calculator, which is pretty straightforward. So what I would like you to do now, I know you don't have graphing calculators at home, so what I would like you to do is go ahead and try this, but I want you to just set it up. So I want you to set this up on your own. And when you get into class tomorrow, you can take a second and plug it into a calculator to see if what you did worked out. I will tell you that there is another way to put this into a calculator that's a little bit easier, which is what that last statement is down here. And we will talk about this tomorrow when we are going through the second example there. So you'll try putting it in the calculator. I'll show you this little bit of an easier trick, and everything is going to be great. I know that you're really excited about math right now and that you want to get to making a really good effort at problem number 2 there. So I will let you go. I hope you have a wonderful evening, and I will see you tomorrow.